I'm going to do a problem I did in class today, so if you came to class and want to see it again, here it is. Or if it didn't come to class, you can look at it. So I want to find a series for the inverse tan. That is, I need to find some series that looks of this form, though the exponents could be different a little bit, it could be 2k or 2k plus 1, is equal to the tan inverse. Now, there's two key ideas. The first, well, this is really the first, is that 1 over 1 plus x squared dx is the tan inverse. We're going to use that. And the second is that if I I can write a geometric series 1 over 1 minus u, then that's my geometric series. We've gone over that. And this is valid when whatever is my u is less than 1. So my method is the first thing I'm going to do is I'm going to write this so it looks like a geometric series. I can get a series. And the second is I'm going to, in order to integrate, I'm going to integrate this. Instead of integrating this, I'm going to integrate the series that that's equal to, and then that's going to give me the tan inverse. That's going to be how I'm going to do it. So the first thing, step one, is this, and so I have to write 1 plus x squared in this fashion, and that's just going to be minus x squared. Okay, so this tells me that I can put this in my series. And I'm going to write this, it's a very good idea to separate that minus sign from the x so it doesn't cause confusion later. So I'm going to write it this way. And again, what the algebra is here, I'll write the algebra here, and then I'll discard it. So the reason I'm getting this is I get minus x squared is equal to minus 1 x squared. So this is all going to be to the power of k. And integral of a times b to the k is integral of a to the k, x squared to the k. So that's going to be minus 1 to the k, x to the 2k. Okay, and that's how I get from here to here. Okay, so that's step one, and the step two is going to be to integrate it. So I'm going to say, okay, my tan inverse is equal to the integral 1 over 1 plus x squared dx. Well, this is equal to this. So I'm going to put this back in here. So I put my power series from 1 plus x squared in here, 1 over 1 plus x squared. And if I integrate it, I'm going to get the tan verse. I mean the inverse tan. So the tan verse, that's like living in the trig verse. Okay, so I get this. And remember, to integrate a power series, we switch it around. Okay. We talked a little bit about why that was in class today. And so this is fairly easy to integrate. The constant doesn't change. Add 1 to the exponent. Divide by the new exponent. So the integral of this is this, but I'm summing it. And then since I integrated, I have a constant of integration. So there's my formula for the inverse tan, but that C is kind of strange. We don't want that there because a formula for something, if it's explicit, shouldn't have any, this is 2k plus 1, let me write that neater. Shouldn't have any unknowns in it except for x. Okay. So what we're going to do is get rid of this. And I just want to show you something. So we're saying that the tan inverse of x is equal to this summation. And I'm going to show you what role that's playing. This is equal to, when k is equal to 0, I get a positive, I get x to the 0. Sorry, this is over 2k plus 1. When x is equal to 1, I get minus 1, which is negative, x cubed over 3. When k is equal to 2, I get x to the 5th, and I think you'll see the pattern. 5, the next one will be x to the 7 over 7, and that continues. Then I have this plus c. So this is really playing the role of the constant term, which usually goes here. Sorry, that's x to the 1. When k is equal to 0, I get x to the 1. So that's really playing the role of the constant term. So now we're going to get rid of the c. And I'll show you. Here, let me just slide this up. So I'll keep this in view. Okay, so we have what we did earlier. And so I want to get rid of that c, and so I'm going to say, okay, what I'm going to use is I'm going to use the fact that the tan inverse of 0 is 0. Okay, it's something I just know, and the reason is that the tan of 0 is 0. Okay, so it's one of those facts. So here's what I'm going to do. I'm going to write my tan inverse formula one more time. I'm going to point out an error that I made in class. Sorry. X to the 2k plus 1 over 2k plus 1. That's what we have here, plus my constant. So what I'm going to do is I'm going to let x equal 0. And 0 is going to be the tangent of 0. In other words, actually what I did is I plugged in 0 in here, and I get 0 is equal to the tangent. But then if I'm letting x equal 0, I'm going to put a 0 in for that. Well, this is just one big fat 0, so all I get left is c. So 0 is equal to c. So my answer is that the tan inverse of x is equal to this. And my c is 0. And if you wanted to spin this out, you would get x over 1. Now I plug in k is equal to 1. I get minus x cubed over 3. And then the pattern continues. So that continues forever. Okay? So that's that.